All right, good afternoon, everybody. Welcome to the next seminar in the U.S. Society for Ecological Economics seminar series. Today we have a guest speaker from SUNY Environmental Sciences and Forestry from the Department of Environmental Studies. It's Emme Christie. He's a PhD candidate, ABD, and his talk will be an Energy Centrality Theorem, the case for the reorganization of economic theory to address human ecological impact. And you can put any questions in the chat. You will also have time to ask questions and make comments at the end. So please feel free to do that. And without further ado, we'll turn it over to Em. Thank you.
Thank you, John. Can everyone hear me?
Yes.
Perfect. Thanks for having me. My advisor is also on the call. Valerie Luzides. She was the one that connected me to this opportunity. So as John said, I'm a finalizing PhD candidate in the Environmental Studies Department, and my PhD research focuses on environmental governance and this idea of resistance in economies or resisting economies, so to speak. So I'll begin sharing my screen. So I did do a sort of last minute change to the title of the presentation. So it's still an energy centrality theorem, but it's the case for reorganization of economies rather than economic theory to address human ecological impact. This topic of interest came out of a class I had with Valerie in spring of 2022 on regenerative approaches for a sustainable future to sustainable futures. And in that course, we spoke about the work of George Scorogan and other ecological economists in terms of introducing entropy as sort of a foundation for understanding economic activity and its impact on on the planet. And so as a chemist, before now, my bachelor's and master's degrees were in chemistry. I took a liking to that topic and wanted to explore it further. So three years later, yeah. So I hope you enjoyed. We're gonna be sharing some background on the economy and society. Much of this is, I think, within this audience is pretty standard knowledge. Um, but it serves as a basis for how we are understanding the economy and our relationships within it and to society and to the environment. And we will overview some concepts regarding the labor theory of value within Marxist economics, and we'll go through the conceptual framework and then show how we apply that energy centrality theorem to the case of climate change as an example. So to begin, centered on the need to reorganize economic processes toward equitably improving social institutions and structures to better support human and planetary health and well-being, there have been several calls for major shifts in how economic activities are conducted. And scholars like Kate Warworth have been instrumental in developing some tools and language for this kind of discourse by painting a clear picture, in my opinion, of how current economic activities have exceeded Earth's ecological carrying capacities without resultant, or rather with only marginal improvements in social conditions for those involved. And so the calls to refocus economic activities toward equitable improvement of social conditions is even now more important than it ever was. However, we realize that Raworth's donut economics, for example, that model appears to have a limitation wherein its focus on improving social conditions does not necessarily equate to addressing key drivers of ecological degradation or vice versa. And this realization, along with some noted limitations of the Brundtland's model, for example, which is the one on the far left, and the ecological economics pre-analytic views of sustainability, which is the one beside it, has led us to reconceptualize sustainability under the premise that the economy um, serves as the mediating force between ecological and social changes or realities. And this, I suspect, is not novel. And additional to that, that relationship also, that conceptualization, we think of mediating relationships when compared to other conceptualization where the three entities are either embedded or partially independent rather than inter or codependent. This suggested model presents an opportunity, in our opinion, to more critically assess our relationships with commodities within systems of economic value creation, natural resources extraction, and more generally, systems of production and consumption. For us, establishing the economy as a mediating force opens up the environment economy discourse space to additional framings that could potentially help in characterizing environmental problems and uncovering solutions that we wouldn't have thought of otherwise. Today, there are increasing calls for a reduction in fossil fuel use, as I'm sure we're all well aware, and reduced consumption in areas like transportation and fast fashion, fueled by the untenable increase in global warming and other ecological degradations, and the concomitant and other social impacts, for example, from climate change. However, reducing fossil fuel use does not necessarily equate to an improvement in socioeconomic or overall ecological conditions. Nor does it mean that climate change as an overshoot condition would be addressed by an improvement in equitable access to energy and food, driven by fossil fuel or an otherwise profit-driven economy. Among these fallacies, we have identified some gaps in current climate change and environmental discourse, such as those that focus on energy transitions and addressing the contradictions of capitalism. Gaps such as the realization that climate change, by its nature as a wicked problem, presents a challenge of language and epistemic barriers that complicate the process of thinking together toward problem facing and solutions making is one of the things that has driven this work. So the goal of this is to offer new perspectives on climate change discourse as an example toward appropriately positioning the economy as the key mediating structure between society and nature, supporting calls for a restructure of economic production and associated theories of value. And we do so by demonstrating that economic activity is the greatest source of global energy reorganization, by introducing equilibrium theory as a unifying framework for understanding energy reorganization as the basis of environmental degradation. And this objective builds on previous works that centered entropy changes. And finally, we do this by establishing the linkages between globalization, energy reorganization, and climate change, what I affectionately call GERC, GERCC. The first step for us in this process was to articulate the role of understanding value. Theories of value form the structure and function of the economy and thereby underpin the understanding of our relationships with energy and commodities. The one of deep value, quote unquote, to us is the labor theory of value, a cornerstone of Marxist economics, which conceptualizes the value of a commodity as being determined by the amount of human labor that goes into producing it. This, we think, is very limited in scope. As Baumgartner wrote in Entropy, a unifying concept for ecological economics, every process of change, be it in nature or economies, can only be achieved by using energy. And as of now, we know that economic activities have resulted in ecological harm, and this comes through the embeddedness and dominance of certain theories of value. And for us, it's those theories of values that emerge from a worldview that separates human work from the work of nature, despite our dependence on those works of nature to drive the economy. So moving a little bit further into this idea of labor, labor is integral to the realization of economic value within capitalist production and is distinguished from work, which is embodied in use values. This is demonstrated in the ongoing proletarianization within the non-capitalist class or of the non-capitalist class. So even though work is done by nature, for example, in growing trees in a forest, producing clean water, or creating the conditions of soil necessary for agricultural production, these products of nature are not seen as having economic value, only use value, since there is no human input, there's no input of human labor until they are either harvested, mined, or used. Within this Marxist paradigm, labor is seen as being provided by social and not biological beings, so humans and not non-humans. Work, however, from a biophysical sense, is characterized by the change in energy of a system. And as such, for us, human labor at its core can be equated to the work of nature in energy terms. This is the idea we develop in our conceptual framework for the energy centrality theorem. And current trends in environmental advocacy, for example, also suggest that there is a push toward broader understandings of value related to ecological and the social impact of economic activities. Also, understanding that trade is a necessary feature of human economies as there are natural limits on what and how much humans can produce, and also understanding that production and consumption are integral to our drive for self-preservation as a species, we believe that it's necessary to understand the provenance of globalization to fully appreciate the centrality of petroleum, for example, and thus energy in maintaining the conditions for continued ecological degradation. Following the birth of capitalism circa 15th century in Britain, the wanton expansion of the bourgeois class eventually led to a scarcity of resources, which led Britain and much of Western Europe to a path of colonization to fulfill their ever-growing consumptive needs. This kickstarted the events which ultimately led to the Industrial Revolution, which have led us on a path to today's globalized economy. The Industrial Revolution was the beginning of modern relations of production and was closely followed by the discovery of the conversion of crude oil into kerosene oil. This latter discovery set the world on a pathway toward the search and discovery of crude oil reserves that would later propel us into today's globalized geopolitical and climate change realities. We therefore continue on to develop our understanding of GERC, the Globalization, Energy Reorganization, and Climate Change Nexus, through framing the economy as the geopolitical locus of conversion of products of nature into commodities for human consumption, with the marketplace representing opportunities of trade for trade. So in this work, we distinguish between the marketplace and the economy, where the market is a part of the economy as relative to neoclassical economics, which basically equates the market to the economy. Recognizing this chronology of economic development, the issues of capitalism, and the importance of available energy systems to their deployment, we began to interrogate the linkages between the current socio-ecological state of the Earth and the linkages to fossil fuel capitalism and historical materialism. We recognized quickly that energy was central to how our economy was organized. While this realization is not new, before 2018, based on current understanding, energy has not been theorized as being central to the subjective utility, which represents a specific theory of value that drives valorization of commodities and thus its influence on consumer behavior and agency within markets. Energy is at the center of the current world order, and while one side of that truth is the capitalist need for accumulation, the other side is human preference for new commodities, as pointed out by Chen in that 2018 paper. The third side of the coin, the edges, previously explored by Costanza in the 1980s, is the waste energy that gets ignored in economic theories. And to this, we add the source of energy, which exists outside the economy, outside the boundaries of the market. Therefore, our research reintroduces energy into economic theory as the base of value theories, advocating for all forms of economic energy to be accounted for during valorization processes. To do this, we operationalize George Scorogan's thesis of entropy as being central to current understandings of economic processes to develop an energy centrality theorem. Underpinned by various entropy laws, this theorem demonstrates the importance of energy reorganization to economic processes and seeks to overcome language and epistemic challenges characterizing discourse on the economic foundations of ecological degradation manifested in issues such as climate change. The laws of thermodynamics are taken as facts undergirding our energy centrality theorem, ECT. These facts are, or laws, neither energy nor matter can be created nor destroyed. Fact one. Fact two, all processes include the use and conversion or conversion of energy. Fact three, all processes generate waste. And four, all isolated systems tend toward a state of highest entropy or lowest energy. And five, all isolated systems tend toward equilibrium. The energy centrality theorem therefore states that the current regimes of economic reorganization of energy result in a high energy end state characterized by the degradation of ecological and social systems and threatens the goal of achieving low energy equilibrium end states as the outcome of human processes. This can further be expressed in two statements. The first, all human processes require the use of energy, which can only be accessed from an already available source and converted into useful forms. This process produces waste. This was one of the things that was realized by George Scorogan, for example, and other ecological economic scholars previously. And the second statement says that all human processes occur with the intent of self-preservation toward an equilibrium or low energy state. That is, human materiality exists for the purpose of achieving the most positive outcomes along the path of least resistance. And this is sort of how we understand what an economy is supposed to be and how it's supposed to function. To show the utility of the energy centrality theorem, we first distill the facts informing the theorem by linking them to more readily perceived observations related to the spontaneous movements of systems toward equilibrium, which is one of the laws of thermodynamics. This is the minus first law, law of fact 5, which states that an isolated system in an arbitrary initial state within a finite volume will spontaneously attain a unique state of equilibrium. Walker and others in 1981 recognized this tendency toward biospheric equilibrium, as we call it, in recognizing that there must have existed a feedback mechanism to reduce atmospheric carbon dioxide concentrations, given that the predicted levels based on prehistoric outputs of 3.3 times 10 to the 14 gram per year, which was enough to double the atmospheric concentration of carbon dioxide in 400,000 years, was never realized. We understand this observation as a confirmation of the minus first law when applied to Earth's climatic system. Ison and others in 2020 identified the silicate weathering system as one of those feedback mechanisms, or further brought to the fore that this silicate weathering system was one of those feedback mechanisms regulating atmospheric greenhouse gases and therefore regulating temperature and ensuring the balance of energy within global biospheric systems. Using the ECT, with an orientation toward understanding these energy changes within the context of complex dynamic systems in dynamic equilibrium, we were able to apply Le Chatelier's principle, which is a chemistry concept, as an equilibrium framework for justifying why current economic processes are to be understood as preventing natural systems from redistributing energy toward re-establishing an equilibrium. And Le Chatelier's principles state that when stress is applied to a system in equilibrium, the system will act to reduce that stress. And for that principle, the only thing that changes the position of the equilibrium is energy in the form of heat. And there are some examples in which we can apply this outside of chemistry setting, for example, pollution studies, um, where we understand that natural systems can accommodate certain levels of input from human waste, for example, before it the state changes. It will absorb and use those inputs, for example, nitrate, phosphate, and beyond that, it changes the system in the form of eutrophication. We also use the example of post-disaster recovery, where we we conceptualize post-disaster recovery in the same way that you are doing everything possible to reduce the stress of the disaster and rebuild towards some state of stability and well-being for society. This helps to shift our focus, this being the application of LCP as the framework, helps to shift our focus from the linear discourse, which links greenhouse gas production to global warming, to climate change, to a more pluralist approach to understanding the complexities of how the economy functions to reproduce harmful ecosocial impacts across multiple spatio-temporal scales. Johan Rockstrom, in a 2024 TED Talk, said, "The window is rapidly closing, but there is still some time in the window." And this is related to climate change. He continued on to say, "We actually have evidence that we've reached a pivotal point, not only in terms of risk, but also in terms of opportunity to transform the world towards a safe and just future for humanity. We need to now recognize from local to global levels that we're all so intertwined that we must govern the planet, the entire planet." And by applying a Chatelier's principle equilibrium understanding, we identified three independent but linked feedback systems. The first system, which is top left, represents the prehistoric processes that resulted in high levels of greenhouse gases being dumped into the atmosphere from volcanic activity. And this was a subject of research from Walker and company in 1981, followed by Lee and company in 2009. This triggered the second system, which is characterized by a series of silicate weathering mechanisms that sequestered carbon dioxide into the oceans, thereby regulating atmospheric temperature and pressure over geological timescales of mega and giga annums. That's 10 to the 6 years and 10 to the 9 years. Sorry, yeah, for example. This second negative feedback system is still functional. However, as economic activities continue to develop and grow in scale and output, a third feedback system developed, and this is the one on the bottom in the diagram. This third system is a positive feedback system, and as an example of how it's a positive feedback, to cope with a warming climate, more fossil fuel is used to develop and power cooling technologies under current economic regimes, for example, and dumping more carbon dioxide into the atmosphere. So in order to cope with climate change, we are reproducing the conditions that cause climate change. And that is a positive feedback. This is bad because continued increase in atmospheric carbon dioxide coupled with increased energy as heat production and the continued decline in forest cover, for example, and increased urbanization mean that the proportion of biotic systems available to utilize produced energy will decrease relative to the proportion of abiotic systems. And so, for example, by cutting down forests for various reasons, including agriculture and real estate, we are putting more pressure on the ocean, for example, to regulate atmospheric temperature. It also means that the discharge radiation from greenhouse gases increases the energy of the biospheric system in equilibrium, leading to the problem of climate change. And so the current positive feedback system functions on a much shorter human timescale of decades to centuries. So we're seeing all of these impacts within 500 years of economic activity. And if we consider the beginning of this to be the Industrial Revolution, we can probably cut that in about half. And it therefore overshadows the natural negative feedback systems, thus continuing to drive climate change by preventing the reestablishment of biospheric equilibrium. We link this to globalization by understanding that current global social and economic organization of society can be understood as a source of the current ecological crisis, such as climate change. And this is juxtaposed against the earlier statement that trade is important because we are naturally limited in what we can produce on a local scale. Social reproduction is also driven by globalized systems of open, capitalist, free market economies, all largely based on fossil fuel energy use today. Also based on industrial agriculture, consumerism, and revenue generation. As we can see in macroeconomic principles analysis, the focus on gross domestic product creates the conditions for more production and thus use of fossil fuel energy. With fossil fuels at the center of this, they are part and parcel of the problem and solution of climate change. This is the expression of the globalization, energy reorganization, climate change linkage, and a demonstration of our earlier claim that the problem and solutions to the climate crisis can be found within our understanding of the economy. The real problem with this is that with this current arrangement is not that we are producing and consuming, it's that the locations of extraction often do not benefit from the resources that naturally exist. Also, those who work in these transformation industries tend to not benefit much. So all the benefits of economic production go towards a capitalist minority who is usually not a part of the location of extraction. So even though there are high levels of productive capacity in capitalism with the potential to improve well-being for all, production is not necessarily driven by demand for any of those things that improve well-being. Instead, it is driven by a demand for profit. And so we contend that despite any challenges to consumer sovereignty approaches, which is rife in political economy spaces today, there must also be some contention with subsequent reconciliation of the production of luxury and of survival goods, and the contribution of these to global energy consumption and outputs. We must also contend with how these systems render whole nations subaltern within the global economy and affects the potential of economic evolution toward equitable systems for economic sovereignty and autonomy. And this is the subject of research from Baer and Company, which focuses on green development rights, for example. So where do we go from here? We must decouple the current thrust toward developing sustainable or renewable energies from the market imperatives that will ultimately lead to the addition of more energy to the Earth system, resulting in what we've introduced as biospheric equilibrium distortions. While the consumption and the reorganization of energy itself is not the problem, the current status quo built on scarcity and competition, coupled with profiteering under capitalist modes of production, has led us on this path of degeneration. And in thinking about human economic activity in terms of energy reorganization, we attribute climate change to the time irreversibility of these processes, creating a scenario where the effects of one set of activities cannot adequately substitute for others. And as such, we suggest that reorganizing of both economic production and associated theories of value are necessary to address ecological degradation, such as climate change. We conclude that to address climate change, for example, global scale changes in consumption behavior is necessary alongside fossil fuel energy becoming transitive in nature. That is, where it is only used to produce essential public infrastructure, with renewables being used to supply our consumptive needs. So for us, at the end of the day, based on this work, we are seeing a future where fossil fuel is involved. However, on this track of thinking about how we organize the economy, we must envision a different place for fossil fuel within the economic structure. So that's the end of my talk. Thank you for your attention and for having me. And we're now open to questions and feedback.
Great, thank you. That was wonderful. There's one question already in the chat box from John Sorrentino. In the minus first law, what does unique mean? Is it with respect to space, time, and other systems, or what? Also, in the biosphere, how does a system get isolated?
So based on my reading of my understanding of the minus first law, unique just means it means distinct. So if we're able and current there are a couple of research that I'm not too familiar with because I've just recently come upon them that have been studying multiple equilibria as it relates to climate systems, for example, in Antarctica. So it is this idea that we are able to isolate and study different systems um with each having their own equilibrium and how that contributes to the broader global equilibrium, which we call the biospheric equilibrium of the planet. Um, and to the second point, I am not certain that it's possible for a biospheric system to become isolated in the sense of these physical laws, because an isolated system requires that there's no external um, transferal of energy or matter.
John, you
Well,
have a follow-up? Go ahead.
you used the word distinct as kind of a synonym to unique. And I still ask, with respect to what? I mean, it's this system is going to reach its own equilibrium regardless of anything else,
Right.
being isolated.
Right. So and so I guess this is where the language comes into play, because isolated here means, it's by itself, right? Whereas isolated in the sense of the thermodynamic laws means that the system does not permit energy or matter flows in and out, right? So isolated is it's not the same thing. However, the system itself is unique, but it is also related to other systems. So there is that transfer of matter in and out of all of those different systems, each having their own equilibrium.
Okay, I'll have to think about that some more. Thank
Right.
you.
There any other questions or comments? Andrew, go ahead.
Thank you for an excellent talk. I really love the ideas you explored and how you put things together. Um, I guess I'm a more quantitative minded person, but I do appreciate what can be lost when you're forced to put numbers to things. It becomes more linear often. But I was curious if you've had any luck with back of the envelope or come across back of the envelope or quantitative uses of this framework or others similar to it.
So in terms of equilibrium, the only things I've seen are the ones from Walker, for example, which looked at the prehistoric systems of global warming, sorry, of the greenhouse effect that made the Earth livable. And the most recent one I've come across is the ISON paper that talks about the silicate weathering systems. And I think it's emerging because there are quantitative studies looking at multiple equilibria in different places, as I mentioned, for Antarctica. Specific to, for example, the foundation of this, which is entropy, the work of George Rogan, that
Hmm.
has just been shelved for the most part. And my next step after this is to actually go back to that from a quantitative perspective, looking at entropy. Because I remember one of the biggest pushbacks to the entropy idea was that because, we were applying Boltzmann theory or Boltzmann analysis to this, and after a certain point, it doesn't hold anymore. So we the argument was that if you continue to produce greenhouse gas, entropy will increase, and that's bad. But based on that framework, after a certain point, entropy starts to decrease again. So, the detractors of George Scorogan's work were saying we can get past this because after a point, entropy continues to decrease, so it's not a problem. But I've started to play around with some computations, and it's crude, but as of right now, um, there may be a tipping point after that secondary decrease in entropy where it just continues to increase unending. But for me, the numbers are so huge, and
Mm.
the time scale begins to go back into geological timescales in terms of when we would be able to see the effect if we applied that framework, which is why I stayed clear of entropy and moved into just looking at equilibrium.
Mm. Interesting. Thank you. I have a astrophysics background, so I'm always curious of these types of talks. Fantastic.
Mhm.
Are there any other questions?
This is just a comment. It was an excellent presentation. I really appreciated the way you were able to break down to be able to understand what you're talking about. And I'm really wondering, how do we uplift the people aspect of this? Because it really is about the people, and how do we get the people to really understand um, how you're going about doing this kind of research?
Um, so within the context of this specific paper, we see we see opportunities based on the framing of human labor being an energetic input also into the system. We see opportunities for sort of rethinking how we value that. And but I guess for me the bigger part is how it links to the idea here that I have of resisting economies of oppression, because this is one of three manuscripts in the whole dissertation. And the other side of this, which would probably be for a different audience, is that climate change as an example of an upset equilibrium or an attempt to reestablish equilibrium is also a form of resistance. So we keep doing, and the earth keeps telling us that what we're doing is not what we should be doing. So there are certainly opportunities for uplifting the people aspect, and I see Valerie has her hand up, so I'm hoping that's what she'll probably build on.
I will just jump in to say what you just said, Em, is where I was thinking of that response back to Deborah, that this idea of really rethinking this social replication of how we organize everything on Earth relative to energy. We haven't been thinking about what that does to impact on those biophysical systems that are now creating these feedbacks that cause things like climate change, that also then obviously influence and impact social degradation. And so it's the connection among these things, trying to establish a means of expressing and talking about the connections among them, because we've kept these conversations largely separate. So I think, yeah. Anyway, that's what I'm going to add over there.
No, and that's what I appreciate about it, because they're all interconnected, interdependent, and interrelated. And until we can show that, that people will begin to really see it for themselves, that you can't separate them. And that's why I was really very interested in, being and listening to him today. I was very impressed, very impressed.
Thank you.
Eric.
Yeah, thank you, Em. That was a fantastic presentation. And I was wondering if you could put back your last or second to last slide that had, I think you had some really powerful conclusions on that. I just wanted to go revisit them, take another look at them.
Sure thing.
So decentralized production, yeah, relocalize it. Fossil fuel to be used as a production for essential public infrastructure, renewables, and consumption. I think that last point, without a shift in demand, the switch to renewable energy has the potential to amount to swapping one problem for another. Yeah, I think this is, I just put in the chat something about, there's a book review um, about energy transitions and how we are not, we have never gone through an energy transition. They've always been energy addition. So we've been using biomass and human organic energy, like you were saying, and then adding on top of that wood and adding on top of that coal and adding on top of that oil. We're still consuming even more of those than we did in the past. We're just keep adding more and more. And these renewables, we're adding that on top of all the other sources. So yeah, without a shift in demand, the switch to renewable energy, we're not really switching, we're just adding. And the demand has to be not just for energy, but for renewables, for clean carbon-free energy.
Yeah,
Um,
agreed.
I think that's you're putting it in a kind of a new context, and I really appreciate that. Thanks.
I think this last bit about the transition is super important because of just what you say. We have not yet done that. We haven't even really been talking about what that is, and there's so much more to the background of this about how we got here and why we got here that I think should also be part of the conversation going forward. It's just a lot all at once. Because if you look at the history of colonization and globalization together, there's such a powerful set of influences that have led us into this situation, that it provides opportunity for us to really, really consider how are we organizing ourselves to sustain life and enhance its quality, and are we doing that in a way such that it's a benefit or useful or beneficial in an equitable way to human and beyond human, obviously taking into account these life support systems that we have.
Mm-hmm.
Are there any other questions or comments?
Would you please review how the labor theory of value came in your analysis?
This is great, John. I'm chuckling because when we started with this, I kept saying, "Tell me again about this," because I think this is really key. So go for it, Em.
Yeah. So in the most simplest of explanations, the labor theory of value was important for me because of that distinction between labor and work. The first time I read it, and the first time I read any Marxist work was probably fall of 2021 because I was a strict chemist before. And I saw this thing and I was like, but how is it different? How is what humans do different from what nature does? Um, and so I think by that helped in the separation of humans from nature. That helps the create the worldview of humans thinking that the things that we do aren't a part of the natural order. Um, and so for me, it was really trying to bring that back from humans in nature to humans as nature. And so it was just basically recognizing that I didn't think labor was different from work, and I was looking for a way to show that labor can be equated to work, and energy change was the thing that did that for me.
So humans are input-output mechanisms which mimic
Yes,
nature,
yes,
but some things are put through markets and some things are not.
right.
So John, so what do you mean? Take that one step further. So some things are put through markets and some things are not. And
Well, in a sense, this is almost a critique of capitalism, right? And labor does, the distinction between labor and work is interesting in itself, but doesn't, to me, get us to the point of, let's say, prioritizing anything in particular for energy transitions. So labor is the expression of energy, but the energy came from getting food to run your system. So I don't know how that translates all the way down to the conclusions in this presentation. Does that make sense?
yeah, that's good. This is super helpful for that clarity to be able to follow it through. Yeah. Thanks.
Any other questions or comments? All right, I'm not seeing any. So before we, I just want to show that our next presentation will be next week. Let me make this a little bit larger. I thought it was big enough. Too big. Veronica Lupi from there's no way I'll be able to pronounce that, but from Amsterdam. So, and her talk will be Climate Policies, Population Dynamics, and the Urban-Rural Contributions to the Social Cost of Carbon. So we welcome you back for that. And then we have 3 other seminars next month as well as in March. And so we've got a good slate of speakers coming up. With that, just want to thank Em very much for the talk. He did an excellent job and look forward to seeing that final dissertation. So thank you very much, Em.
Yeah, thank you all for having me.
Have a nice weekend, everybody.
Take care, everyone. Bye-bye.